Hello everyone. Okay, so in this video we are looking at conditional probability. So what is conditional probability? So conditional probability is usually written like this. P bracket A line B end of bracket. This is pronounced the probability of A given B. So that just means the probability that something happens given this other thing has happened, right? So conditional probability is a probability of event A occurring given that event B has already occurred. So for example, given that you drew a red card, what is the probability that it's a 4? So what's the probability it's a 4 given that it's red? You know, so I pulled out a card and you asked me, and I told you, okay, it's a red card. What's the probability? That's what conditional probability means, right? And how we calculate conditional probability is probability of A given B is equal to probability A intersection B over probability B. So remember, A intersection B just means the probability of A and B happening over the probability of B. So let's have a look here. The numbers 1 to 9 are written on cards and placed in a box. A card is drawn at random from the box. Find the probability that the number is prime given that it's odd. So I'm looking for the probability that the number is prime given it's an odd number. So I now need to find the probability it's prime and odd over the probability it's odd. So what's the probability it's prime and odd? So numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. So which one of these are kind of prime and odd? Well, 3, 5, 7. That's it. So that would be 3 over 9, because I have 9 kind of total things here, over the probability it's odd, 1, 2, 3, 4, 5. And it'd be 5 over 9. So the probability it's prime and odd divided by the prime given it's odd. So it's going to be 3/9 over 5/9, which is the same as 3/9 divided by 5/9, which is the same as 3/9 multiplied by 9 over 5, which is 3 over 5, which is 0.6. And that makes sense, right? So probability it's prime given it's odd is 0.6. And then let's look at the Venn diagram. Use the Venn diagram, write down the probability of A given B and the probability of B given A. So the first one here, probability A given B, well, that is the probability that A and B happen all over the probability B happens. So looking at my Venn diagram here, A intersection B here is 0.1. Put that on top. And the probability B, so I need to add up the probabilities in here, which that would be 0.1 plus 0.3, which is 0.4. So the answer here would be a quarter, or 0.25. So the probability that event A happens given B happens is 0.25. And second one here, probability B given A, that's the same as probability B intersection A over probability A. That is the same as 0.1 over A is this big circle here. 0.4 plus 0.1 is 0.5. That's the same as 1/5, which is 0.2. Right? And that essentially is conditional probability. So we're going to look at some questions now. But just something to note about conditional probability. Right? If independent, right? If independent, right? So if two events are independent, meaning one event happening does not affect the outcome of another event happening, right? The probability A given B will just be equal to the probability of A, right? Which makes sense, right? Because what's the probability A is going to happen given B happens? Well, if they're independent, it doesn't matter if B happened or not, because A will still have the same probability of happening. Right? So A given B will equal to probability A if the events are independent. Right. Right, just a recap here of independent and multiplicity rule. So independent events, like I said, are two events wherein the occurrence of one event does not affect the occurrence of another. The simplest example of such events is tossing two coins. Right, the outcome of tossing the first coin cannot influence the outcome of tossing the second coin. Right, so mathematically, right, so independent events, right, A intersection B will equal to probability A times probability B if they're independent, right? And like I just said, that it conditional probability A given B is just equal to probability A. So just remember, the word and in probability corresponds to the intersection of the events denoted by A intersection B, i.e. when the i.e. probably that both events happen. So let's just look at some questions here. So two events A and B, such that probability A is 3/4 and probability A intersection B is 1/2. Find B given A, give your answer as a fraction in its simplest form. So probability B given A is going to be equal to probability, so A intersection B over probability A. Right, I know what probability A is and know what A intersection B is, so it's going to be 1/2 over 3/4. Put down your calculator. 2/3. Then, if A union B is equal to 11 over 12, investigate if A and B are independent. So remember, A union B, that's the same as probability A. That's probability B minus the intersection. That's my addition rule. So probability A union B, well, that's 11 over 12. That's equal to 3/4 plus the probability of B minus 1/2. So the A intersection B is 1/2. So when you rearrange and solve for B, you'll get the probability of B is equal to 2/3. Right? Well, they are independent, as probability B given A is equal to the probability of B. They both equal 2/3, right? So B given A is equal to 2/3, probability B is equal to 2/3. So therefore they're independent. Or we can just test the probability of A intersection B equals probability A times probability B. So this is 1/2 equals, so probability A is 3/4. Probability B, we're saying is 2/3. Let's see if these are equal. 3 times 2 is 6. 4 times 3 is 12. 1/2 is equal to 6 over 12, which is equal to 1/2. Therefore, A intersection B does equal probability A times probability B. So therefore, it is independent. Right, let's just look at some quick questions here. So, a bag contains 9 identical discs numbered 1 to 9. One disc is drawn from the bag. Let A be the event that an odd number is drawn, and let B be the event a number less than 5 is drawn. What's the probability that a number is drawn less than 5 given that it is odd? B given A, probability B intersection A over probability A. So I kind of calculate the probabilities now. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 1 to 9. A is the event an odd number is drawn. I have 1, 2, 3, 4, 5. So A intersection B is 5/9. Probability A is 5/9. Probability B, let the event be a number less than 5. So B intersection A just means an odd number less than 5. How many odd numbers less than 5 do we have? Well, we have 1 and 3. My answer here is 2/9. Put that in your calculator. I'll get 2/5 or 0.4. And what is A given B? Explain in words first and then evaluate it. Well, A given B is just the probability that it's less than 5 given it's odd. Nope. Swap it around. Given it's odd, A is it's an odd number. B is it's less than 5. So what's the probability it's an odd number given it is less than 5? So do it out here. When my intersection is 2/9, we know that. Right, I have to put over the probability it's less than 5. Well, that's going to be 4/9 because 1, 2, 3, 4, 4 numbers are less than 5. And then let that equal to, that'd be 2/4 or A. Right. Are events A and B independent? Justify your answer. Are they independent? Let's see. So if they're independent, A intersection B should be equal to probability A times probability B. Well, A intersection B, we established as 2/9. Probability A is probability that an odd number is drawn. It's 5/9. And probability a number less than 5 is drawn is 4/9. Multiply them together, you get 20/81. 2/9 does not equal 20/81. Right? Therefore, not independent. Right. One more here. Let A and B be independent events. Okay, that seems important. Such that probability B is equal to 0.75 and A union B is equal to 0.78. Find probability A in section B. So I notice here I have two unknowns, right? So I am going to need to kind of make one of these X. So I'm going to say let the probability A equal X. Okay. So I have probability A union B. That's equal to probability A plus probability B minus the probability of the intersection. So if I can write A intersection B in terms of probability A, then we're doing well. What do I know? Well, I know they're independent. That means A intersection B is equal to probability A times probability B, which is equal to X times probability B, 0.75, 0.75. So, and I know probability A union B is 0.78, so 0.78 is equal to X plus 0.75 minus 0.75X. 0.03 is going to be equal to 0.25X. Divide there. Yes. X is equal to 0.12. So probability A is equal to 0.12. Probability of A intersection B then will be equal to 3/4 of that, which is 0.08, I think. 0.09. Right, because probability A intersection B is 0.75 times. Right. This one here. Let M and N be independent events, such that probability M is 1/3 and probability MUN 2/3. Find the probability of N. Right? Find the probability of N. So they are independent events. So I also need now to know intersection of these events. But I know that'll be probability N times probability M. And I'm just going to say the probability of N is X. And I'm going to multiply that by 1/3. X times 1/3. Right, so 1/3 X. So probability M union N is the probability of M plus the probability of N minus the probability of section N. That would be equal to 1/3 plus X minus 1/3 x is equal to 2/3. 2/3 is equal to 1/3 plus 2/3 x. That would be 1/3 is equal to 2/3 x. 1/3 divided by 2/3 is a half. So x is equal to half, or probably n a half. And find n given m, so probability of event n happening given m has already happened. That would be equal to probability n intersection m all over probability m, which is equal to 2. So n intersection m, that is 1/2 times 1/3, so it'd be 1/6 over, because this is probably the intersection. So it'd be 1/3 times 1/2, which is 1/6. All over the probability of m happening, which is 1/3. Put that together, get 1. Right? Or the other way of doing it is there are independent events. So n given m will be equal to probability of n, but they are independent. Okay, let's just look at one more example here. This is from 2024. So this one's a bit tricky. So PK Hotels are testing a new booking system. 45% of people who log on to the PK Hotels website are shown the old booking system. The other 55% are shown the new booking system. People are assigned the booking system, old or new, at random. 1/3 of people who see the old booking system end up booking the room. 2/5 of people who see the new booking system end up booking a room. One person is selected at random from those who have booked a room, PK Hotel's website. Find a probability that this person used the new booking system. This is a lot. So let's just figure out what they asked me to find first. Ask me this. So one person is selected at random from those who booked the room, right? Through the hotel website. Find a probability this person used the new booking system. So what I'm looking for is the probability of the new booking system. They used the new booking system given they booked. So that is what I'm looking for. I'm looking for n given b. Probability they used the new booking system given they booked. That is probability n intersection b all over probability b. So the probability that they use the new probability they used the new booking system and booked a room in the hotel over the probability that they booked. So let's read through the information here. So 45% of people who log onto the website are shown the old booking system. 55 are shown the new booking system. So 55% of people are shown the new booking system. So the probability, right, that they're shown the new booking system is 0.55, and the probability to show the old booking system is 0.45. 1/3 of the people who see the old booking system end up booking a room. 2/5 of the people who see the new booking system end up booking a room. So this would be the probability the old booking system and they booked, the probability of the new booking system and they booked. So O intersection B. So old booking system and they booked. Well, that's going to be 0.45 times 1/3 there, which is equal to 0.15. What's the probability to use a new booking system and book the room? That's 2/5. So 0.55 times 2/5 is equal to 0.22. So 1/3 of the people booked the old system. So, and now 2/5. So N in section B. So how many people booked how many people use the new booking system and booked a room? Well, that is 0.22, which I calculated up here. Now I need to calculate, okay, now I need to calculate the probability that they booked a room. Right, so what is the probability that they booked a room? Well, these are the only probabilities they booked a room, right? They either use the old booking system and booked a room, or they use the new booking system and booked a room. So the probability of booking a room is just 0.15 plus 0.22. So it'll be 0.22 over 0.37, which is equal to 0.59, but that's the nearest percent. So it'd be roughly equal to 59%. Yeah, well, 0.5945. That's the nearest percent, and the nearest percent will be. Right. Anyway, that is kind of conditional probability and some questions there. I hope this video was some help to you guys, and I'll catch you guys later. Bye.